Hey everyone, we're back to do number 7 and 8 on the exam. So we're on to naming, and just to review naming, I have posted this document for you guys, this IUPAC name nomenclature scheme. So just a few little summarized pieces from this, and I really do think it's helpful if you print it out and look through it. So it's definitely not comprehensive. It doesn't talk you through all parts of naming, but it does give you a picture of what IUPAC is thinking when you're trying to construct an organic name. So the naming, that blue book actually includes different naming schemes that's like 1,000 pages long that IUPAC has written about this. But the one we're looking at is called substitutive naming. And this is how they think you should construct a name. These are all the possible parts that an organic name can have. And instead of reading it front to back, let's start in the middle. This is the name of the parent, how many carbons are in the structure that you're trying to draw. And then these are the endings to tell you about the bonds between the carbons. Ane is single bonds, ene is double bonds, ine is triple bonds. Then from there, you have to start building out what else is going on with this molecule. So extra things that are attached can either be functional suffixes or detachable prefixes. And depending on priority, the same molecule or the same group attached could be in either one of these locations. So a functional suffix would be the highest priority of the groups attached, where all of the lower priority groups would be written down as detachable prefixes. So an example of that is an NH2 group attached will be called an amine if it's the highest priority, or amino if it's a lower priority. Then you have some non-detachable prefixes. That's like cyclo if the molecule is in a ring instead of a chain or branching. And hydro, dehydro, you'll learn about that a little bit later, so I won't give that one away. That one's probably pretty rare. You could probably do without ever learning that, even in this class. It'll only come up once, I think, in this course. And then cumulative suffixes if you're trying to name an ion, which you definitely could name if it has, or a radical, if it's lost electrons or gained electrons, you could choose to use cumulative suffixes. And the second page actually retells you what I just told you about each one of those different groups with some examples. But what I want to get to, which is what's relevant here for question number 7, is this. This is the order seniority of classes. So IUPAC has a lot more classes here, but this is what you should get you through the class quite well. So what I want to show you here is that this is the priority group. So we've seen things like an alcohol attached. We've seen things so far like halogens attached, and we've definitely seen things like alkenes, which of course is double bonds, alkynes, and alkanes. So this is how they would take priority in naming. So these are listed as endings, so that these show up here, endings. You get the parent, which is the number of hydrocarbons, then the ending, which would be ane, ine, or ene, and then the functional suffix would be added on after that in this order of priority. If after you've got the highest priority one put in as a functional suffix, then you go back and start adding things as detachable prefixes. These are the prefix names for all of these groups. And then also things like alkanes can be listed as detachable prefixes, and halogens can be listed as detachable prefixes if they're substituents on the group, but not part of the main chain for alkanes. So with that in mind, that's how we're going to try to write down names for these. The first thing we're going to try to do is start right at the middle and try to figure out what the parent hydrocarbon is. So the parent hydrocarbon is just the longest chain with the highest priority functional group attached. And to consider the highest priority functional groups, you only have to look down to here. If it's just an alkane, you just have to look for the longest chain. So we're looking, sorry about my daughter asking for Cheetos in the background. That's what 3-year-olds do. So we're looking for just the longest chain for the parent here because we have an alkane. So you can trace that anyway, but here it is essentially. 1, 2, 3, 4 carbons in a row. And you could count it 1, 2, 3, 4, or 1, 2, 3, 4. So 1, 2, 3, 4, or 1, 2, 3, 4. Either way, it's a 4-carbon chain, so that is a bute. Hold on 1 second. Sorry, I had to cut out there again for a second, but we're back again for another try. Okay, so we had counted the carbons in the longest carbon chain. It's an alkane. So we know it's going to be 4 carbons. And again, that's the parent. We're looking for the longest carbon chain that has the highest priority substituent attached, and or functional group attached. And we don't have those. We just have an alkane. So we're just simply looking for the longest carbon chain. So we found the longest carbon chain, 1, 2, 3, 4. That'll be bute. We know that there's all single bonds. So the ending part is going to be the ane. It's going to be the bute and then the ane. Now we need to look and see what kinds of things are attached. And here we really only have 2 things attached. So those are this bromine over here, and then this. So luckily, none of you drew a structure quite this complicated name, but it's not too bad. When we name things, these are all going to be detachable prefixes out in front. So they're going to get the just halo naming. So this is bromo. Sorry. This is going to be called bromo. And then this one is actually the worst because it's a methyl and a fluorine. So it's going to be fluoromethyl. So essentially you pretend like you didn't have the rest of the molecule, and that would just be fluoromethane, right? So we would just name it fluoromethane, except it itself is then attached to a carbon chain, so we call it fluoromethyl. And that's how you name them, and it's both on this chart as well. For prefixes, you use the halo alkyl names, so fluoromethyl. Now we just have to decide the proper numbering scheme to use. Do we number from this direction or this direction? And the general rule overall is you just number here, because none of these have any higher priority. You just give it the lowest numbers overall. If you had something with high priority, like an alcohol group, you would give the alcohol the lowest number. So these have equal priority down at the bottom of the list. So we just start with the lowest number, which will be right there. So now we can go ahead and construct our name, which will be, you can start at the beginning. It doesn't really matter. So it'll be 1 bromo, 2 fluoromethyl butane. So there's the parent, 4 carbons, single bonds. On the first carbon, there's a bromine, and on the second carbon, there's a methyl that has a fluoro attached to it. And luckily, you guys didn't draw molecules that were quite as hard to name as this one. You didn't have any halo methyl groups attached, so you were able to name it even a little bit easier. You all put your halogens on the parent chain, which is the easiest way to name. So now this one, though, is named very similarly, except we do have a group that falls on the list. We now have an alkene that gets priority. So now we name it the same way, and it's going to get almost the exact same name, except that our alkene has to be in the parent chain. So it actually is in the same chain, so we're going to end up naming it exactly the same way. 1, 2, or numbering it the same way. It's on that parent chain. I didn't put the alkene up here or something, so we don't have to deal with that, with changing the parent chain. So we're going to name it the same way, except for one more thing. We're going to call it same way, 1 bromo, 2 fluoromethyl butene for the double bond, except we have to tell you first off where that double bond was located. So we'll say but 1 ene. And then 2, we have to tell you what configuration it's in. Is it in the E configuration or the Z or the cis or the trans, depending on what you're doing. Since we have complex groups here, we have to do the EZ system. And it's pretty easy to tell here which one it is. This is a hydrogen. So out of these two, which is highest priority group? This one is highest priority group. Bromine is much bigger than hydrogen, so that's pretty obvious. And this one as well. This is a CH2 attached to a CH3. This is CH2 attached to a fluorine. So this is the highest priority group, and that's the second highest priority group. So we have our highest priority groups on the same side, and that's the Z. We always say it sounds like you're a 70s vampire or something. It's on the same side. So this is the Z configuration of the double bond. So that's how we'll name those. Let's go on now to question number 8. So now we need to draw an isomer of our molecule and of the alkene that we drew. So the basic isomers that we've been talking about are what we call constitutional isomers. So some people call these structural isomers. I was sort of expecting to say constitutional, but because that's what our textbook says, but it's also common to call them structural. So a lot of people did that. That's totally fine. That's just a different rearrangement of the atoms. The other type of isomer that you could have done here would have been the cis-trans or EZ isomers. Cis-trans and EZ isomers are part of what we call stereoisomers. And cis-trans and EZ is actually one of those. The other of those we'll learn about next, which is asymmetric centers, and that's in a future chapter in this next unit coming up. So we'll just say that's coming soon, the other type of stereoisomer. So I expected most of you to draw one of these two with each of them. And that ultimately is what I saw, mostly constitutional or structural isomers. So if we go back to what our molecule was, here, original molecule, an isomer would just be like the straight chain version of this. So we could just go right back to it and draw 1, 2, 3, 4, 5 carbons, and then put the bromine here and the fluorine wherever we felt like. And that would be constitutional or structural isomer of that. We could do the same thing with the double bonded form. Or we could choose to draw the cis-trans isomer. We could just make it a straight chain, move some atoms around, branch it at a different place. Or we can draw the other isomer. Since we had already drawn what we determined was the Z isomer, we could just draw the E isomer. So for that, we would just basically draw this same thing, draw our double bond in the chain, draw the branch up here to fluorine, and then instead of putting our bromine up, put our hydrogen up and our bromine down. And that would then be the E isomer. So you would say that was a cis-trans or an EZ isomer, or you could have called that a stereoisomer. It's weird to call it a stereoisomer because that's a category that includes cis-trans, EZ isomers, and asymmetric centers or chiral isomers. There's other words for that too, but I don't want to get into that yet. So that's pretty much it. That's question number 8. Stay tuned next for question number 9, and that will be the complete exam. Thank you very much for watching these videos. See you next time.